We are focusing on electric vehicle inverters, so DC to AC converters, and we are developing our devices to be very efficient for high power and very reliable.
Hi, it's Eamon with ipXchange. We're at the VisIC booth talking to Dima about D3 GaN. I have no idea what this is, so Dima, would you like to explain what is D3 GaN?
Definitely. So D3 GaN is a direct drive D-mode gallium nitride device. We are utilizing a D-mode gallium nitride power device that provides much better reliability, both for gate and the whole device. And our direct drive system allows us to toggle the GaN gate. Okay. So we are utilizing the great performance for switching times and very low switching energy that the D-mode gallium nitride device allows us. And by driving the GaN gate directly, we are not suffering from issues that come when you are trying to drive a MOSFET that is usually used in the cascode system.
So I guess
versus an E-mode device, sorry.
This is all right.
And versus an E-mode device, we have a larger margin for the threshold voltage. So driving the gate is much easier. It puts less constraints on the system level development for the power electronics engineer.
Cool. So just to be absolutely clear, you don't need a separate GaN driver with these devices, do you?
We need a gate driver. It's an external driver. You can use any of the shelf driver that you size for your application, but we are driving the gallium nitride die directly. We are not driving a MOSFET like is usually used in other D-mode companies.
Cool, understood. What are these some evaluation boards, reference designs that use the D3 GaN?
Yes, those are evaluation boards that we use internally for testing and provide for our customers as well to evaluate our devices. Those are the basic half bridges that you can use for multiples testing, for switching energy measurements, and for high power operation, for buck boost, even a full bridge setup.
Cool, nice. What type of applications do you usually see these devices being used in by your customers?
So as a power device, it's quite agnostic to application. We as a company, a startup company, need to focus. So our focus is very, very clear. We are focusing on electric vehicle inverters, so DC to AC converters. And we are developing our devices to be very efficient for high power and very reliable because we are aiming at the automotive world. That's why the differentiation of the D-mode gate that has a wider margin for the threshold and a much higher breakdown voltage allows us to move to such applications.
Off the top of your head, do you have any numbers for that? As in what the threshold voltage and the breakdown are?
So the threshold voltage of the device is 8 volts.
That's good.
And the rest we need to discuss
fair
under
enough.
NDAs and such. But
you're that kind of startup. Nice.
Much less constraints on the system level design. So guys that are familiar with, or girls, people that are familiar with designing with devices that has 2-3 volts threshold voltage and the breakdown is 7-10 volts, we are a completely different story.
Cool, nice. I think that's everything I really wanted to ask. So, actually, so you say you're a startup, but are these available at the moment?
Yes, you can have our evaluation boards. They're available. You should contact our salespersons.
Cool, excellent.
Both in Europe and US, Asia.
Cool. Whereabouts are you based?
So our headquarters are in Israel.
Most
of the R&D team is in Israel, but we also have a new power electronics team that we are establishing in Vienna.
Cool.
We have representatives here in Munich, We have an R&D lab concentrated on power modules in Phoenix, Arizona.
Okay.
And we also have people in Taiwan and in China as well.
So you've got a good global coverage for support if anyone was to start using your
both
devices.
for R&D and business development.
Nice, excellent. But that definitely solves all the questions. I like to always ask at the end of this. I mean, it's the first day of PCIM. How are you finding it?
Well, that's very interesting. There are a lot of people, a lot of traction. People are coming asking hard questions, so that's always interesting as an R&D person.
Yeah.
We are very interesting to see how people can find new ways to utilize our device. Being a very high-performing, fast switching, the switching frequency is limitless. We can talk about megahertz switching, so you understand that you can utilize it in many, many different applications.
Cool. Well, it sounds like if you want to learn the real spec, you'll probably need to really talk to these guys under NDA. But it's been really, really good to talk to you, Dima.
Thank you.
Great technology.
For the opportunity.
Cool. Thank you.
Right. Thank you.
So that was our chat with VisIC about their D3 GaN, another GaN solution, again done very, very differently. If you'd like to learn more about the two half-bridge evaluation boards, head over to the ipXchange website in the description.